Hi guys, welcome to a new video tutorial in which we are going to show you how to name and draw structures for your hydrocarbons. This is naming your hydrocarbon.
Hi, I will talk about the hydrocarbons. They are organic compounds that are composed only of hydrogen and carbon. If they have one bond, they are alkenes. If they have two bonds, they are alkanes. And if they have three bonds, they are alkenes. And finally, there is the aromatics or benzene that are ring of 6 carbon atoms with one hydrogen atom attached to each carbon. These ones are unsaturated. Just alkanes are saturated.
Well, before start naming the different compounds that include the alkanes, alkenes, and alkynes, you must understand what is a alkyl group, or also known as a substituent group. The definition of each one, is also the same and talks about the same too, but they change about little in the structure of how these define each one. In a substituent, they appear to substitute for a hydrogen atom in a parent chain or main chain in which the double bond or triple bond appears, or maybe just in the alkane that is the largest one. And for the alkyl group, it is an alkane that is missing one hydrogen atom. About the ending, they have the ending of "il" and it's gonna be the same as "ein," "ein," or "in," but in this case it's gonna be put after the prefix of the different glomerulus series that exist between the alkanes that have a missing hydrogen atom. And well, they also reach the number of N of decaying, but without one hydrogen ion, but they are not really common. The main ones that appear a lot are, well, these ones that you have here in blue color. And well, that's all. After learning what is a alkyl group or substituent group, we must also understand and learn what is a alkene. These ones are classified as saturated hydrocarbon. This means that the carbon atoms of the alkanes are going to be bounded to 4 hydrogen atoms or 4 atoms or other element, like in this way. As well, the way that they are bonded is just single. They don't have triple nor double bond. They are always going to finish with the after the prefix with this little word, the "ein." Then, when they don't have any kind of substituent on the main chain, they are gonna be called as like homologous series. This means that they are gonna differ. Well, a lot of their compounds, series of compounds of them, are gonna differ on a simple unit, which one is this, the CH2. They're gonna differ on the quantity about how many they have, and depending on that quantity, they're gonna call like methane, ethane, propane, and butane. These 4 are the main ones, the principal ones. And after the fifth, the pentane, hexane, and so on, it's really simple. This prefix, we have already learned them in math on another kind of subject. But the first 4, we must learn them because we have not worked with them before. The general formula is CnH2n2, which means in which the N stands for the number of carbon atoms and is used to calculate the number of hydrogen and carbon atoms. Then, after all of this, we must also learn how to name the alkanes by following the rules of UPAC. This means that we have structural formulas and cyclic structural formulas too, or cyclic formulas. In this case, we must look for the main chain, which is this one, the largest one. It can be up or down, or to the left or to the right, doesn't matter, but must be the largest one. Then we must look the side on which we have on the second, or is near, or is more to the end, or well, to the beginning, near to us, and the substituent. If we have a substituent on the second position and on the third, we're gonna take the side of the second position. But in this case, it's symmetric. We have a methyl and ethyl. In this case, we must take the wave that is using the alphabetical order. So we're gonna take the ethyl because it begins with E and methyl is well with M. So we're gonna start counting from this side to this other one. So it's gonna be ethyl in the position 2 and methyl in the positions 4 and 5, and we start writing the name 2-ethyl hyphen 4,5 hyphen dimethyl extended, and that's gonna be the name for this one. Then we have the cyclic one. In these ones, we must start counting from the side or to the other in which we have less spaces occupied by these substituents. If we have an ethyl in the middle and a methyl in the other side, it doesn't matter because maybe you will think that we must start counting from a alphabetical order, but in this case, no. We must count to the side that we have less. It doesn't matter if we have a ethyl on the order or not. So in this case, we have a methyl and an ethyl, so we can start from the right to the left. So we have 1, 2, and 3. So 1 ethyl hyphen 2,3 dimethyl cyclooctane, because we have a 8 carbon bonds to the hydrogen. It's like 1, 2, 3, 4, and 5, 6, 7, and 8. But we are gonna just count the 3 because this is where the substituents are going to be found. Okay, I'm gonna talk also about the alkenes. They are classified as unsaturated hydrocarbons. The number of bonds that they have between their carbon atoms is 2, the double bond. Their compounds are always going to end in this with the 3 final word letters or words, which are pronounced like in. The original formula is CnH2n, about which the letter N we have already known that the letter stands for the number of carbon atoms that they have on their compounds. The hybridization is sp2, and well, that's all the characteristics and information about the alkenes. But we also must learn how to name their different compounds or structures that we can find maybe on the exam or somewhere else, and well, to name it correctly. When we have a structural formula, we must identify the main chain where the double bond is located. It doesn't matter. It must be linear. It cannot be like linear and then turn left, turn right, or go up, go down. It must be linear. Then, after start counting them, we must start counting from the part or the side from where the double bond is near. We are not gonna focus on the substituents as like in alkanes. In this case, we had the double bond in the position number 2 and the substituent in the position number 4. So we start counting them, and then we write it in alphabetical order. The order will be like 4 methyl, 2 benzene, and that will be the name of this compound of the alkene. And the rules for that the UPAC has established are gonna be the same that we use in the alkenes. Just gonna change the way the one that established that we must start counting from the side that is near to the double bond. Then, when we got a cyclic one, we are gonna call it as well the number of carbons that it has on this cyclic chain, and with the cycle. That's the name, and the other rules about start counting from the double bond are gonna be the same. In this case, we must start counting to decide that we are gonna obtain the position of each one of the substituents, or well, the range of the substituents where they are gonna be found a little short. So in this case, we cannot start counting from right to left. In this case, it's gonna be from left to right. So we start counting like 1, 2, 3, and 4. And maybe some of you will ask yourself that we must start counting as in alkane if this is symmetric by the one that has by the substituent that has the first letter in the alphabetical order. But in this case, we must focus on the double bond. So we start counting them, we localize each one, and mark their position. In this case, And at the moment to start writing the name, we're gonna start by we're gonna use the alphabetical order. So it's first ethyl, then it's methyl, and at the end is cyclohexene. So we start writing the name as with the position and separated by hyphens and commas if it is necessary. 3 ethyl, 4 methyl, and 1 cyclohexene, or well, in this case it's just 1 because we have only 1 double bond, but if we have 2 or 3, it will depend. And instead of this cyclohexene, it's gonna be cyclohexdene or cyclohextridene, and that's all about the alkenes.
The conclusion was that the hydrocarbons are something of great importance for our civilization. We need to learn how to classify them because of that importance. For knowing how to improve something, we need to know how to measure it, and for measure something, we need to know it. That was our thing conclusion. My personal reflection is that our civilization depends on them, so we need to know all of what we can know about them. It is something quite dangerous to don't know something about something of which you depend. So that's the reason for all our need of study chemistry. Not only the hydrocarbons, but all chemistry. Without it, we will be nothing. We need it a lot to continue advancing. We need to have more knowledge about them.
Activity I have learned a lot about the hydrocarbons, the characteristics, properties, and how they divide in the different classification that they have. But also I have seen and learned that they really contribute to the pollution in a really bad way. About this, we must think and understand that we need to replace them, to change that. In this case, to design or maybe find another source of energy that will be really harmless or will not contribute to the pollution.
My personal reflection is that when you know how to the roles of the molecular formulas like alkanes, alkenes, and alkanes, it's not difficult to identify them and to classify them.
My conclusion is that we need to know the UPAC rules to name compounds, because without them, then every scientist or chemist will be confused in how to name a compound, and no one could repeat that same chain. So with these special rules, we can repeat the chain without mistakes.